Class Test 1, Question 9. Integrate 1 over x squared plus 5x plus 6. We can't integrate this expression as it stands, so what we're going to try to see is whether we can split it into two linear terms. Looking at the expression in the base, it's clearly factorizable into x plus 2 times x plus 3. And choosing two variables at random, we're going to write this as a over x plus 2 plus b over x plus 3. And then putting those two expressions over a common denominator, we can write a times x plus 3 over x plus 2 times x plus 3 plus b times x plus 2 over x plus 2 times x plus 3, which means that the right hand side and the left hand side are over a common denominator. So we can write 1 is equal to a brackets x plus 3 plus b brackets x plus 2. So expanding the brackets and collecting the like terms, we can rewrite that as there's ax, there's bx, so that's that term there, that's 3a and that's 2b, so that's those two terms there. Now, comparing the coefficients of the terms in x on this side and the terms of x in this side, we can write a plus b is equal to 0 because there are no terms in x on the left hand side. And then looking at the constant terms, we've got 3a plus 2b is equal to 1. Now from the first equation here, we can see that a equals minus b, and I've run out of space, so let's move this up a little bit. B equals minus a, and substituting that into question 2 here, we can see that 3a minus 2a is equal to 1, so a is equal to 1, and if a is equal to 1 from this one, b is equal to minus 1. So substituting that into here, we can write the integral is the integral of this term plus this term, and these are linear terms in x. Each one of those can be integrated. That's going to be log to the base e of x plus 2, that's going to be the log to the base e of x plus 3, plus the constant of integration. And we remember that subtracting logs is the same as division, so we can write that as log x plus 2 over x plus 3 plus a constant of integration. So part 2, integrate 1 over x squared plus x plus 5 over 4. We start this integral by completing the square. So we're going to get an x squared term plus a constant term is what we're looking for. So we're going to add half of the coefficient of this term here, half of the coefficient of that term there, and that's minus half of the coefficient of that term. And a half squared is a quarter. 5 quarters minus a quarter is obviously going to be 1. We now have an expression of something squared plus 1, which makes us think of tan squared plus 1. So if we let x plus a half equal tan, differentiating that, we're going to get dx is equal to sec squared du. And putting that back into the integral, we're going to get tan squared plus 1 from here, tan squared plus 1, dx is replaced by sec squared u du. Now tan squared plus 1 is equal to sec squared, so the integral becomes sec squared u du over sec squared. Sec squared cancels with sec squared, so we've got the integral of du, which gives us u plus a constant of integration, and then back substituting for u from here, we're going to get arc tan of x plus a half plus the constant of integration, and that's the answer to part 2.